it's recording and you should be able to hear me. I'm looking at a question from task 4 on math space on quadratics. This is using turning point form of a quadratic and graphing. So it says the graph of y equals minus x plus 2 all squared is translated 3 units up. Okay, so what equation? Well, I've already got most of the equation. I just need to move all the points up 3. So whatever the y's values were, they're now going to need to be increased by 3, and that will move the curve up by 3. Okay, so that's very easy. It's just plus 3. We'll take all of your y's and put them up by 3, therefore translating vertically upwards. For this graph, what is the largest value of y? Okay, there is a maximum value here, and it's because this graph is concave down. I know that because of this minus here, right? So we have a concave down shape, right? The turning point will be the highest point on the graph, giving the largest value of y. I can get the turning point from the 2 and the 3, right? And they're asking for the y value, so it's 3. So I'm using the formula y equals x minus h all squared plus k, where the h and the k value are the turning point, right? What x value goes with this point? Well, it's here, it's the 2. You need to be careful because it's a minus 2. Right. And you can get that from your turning point formula. I don't know if I can try and write it using the sketch pad. I'm talking about this. Y equals some a value, x, sorry, I don't have a proper pen to use, minus h, whoa, dodgy, squared plus k. All right. This equation I'm dealing with here, if I graphed it, would result in a downwards parabola, concave down. The largest value, they keep asking me about what's the largest value of y, what x value results in the largest value of y. They're talking about this maximum point, max, and it's at the turning point. And the turning point is coming from h and k, like so, right? So because the quadratic is in this form, I can read this turning point off really easily. It's minus 2 and it's 3. Okay, so I'll get rid of that, and I want to delete that thing. It's awful. How do you delete it? I don't know. Oh, clear. Okay, yeah, clear that. All right, good. Close. Now, yep, we did that. H and K. The axis of symmetry running straight down through the middle. Well, that's running through the turning point. The turning point's being given here. This is a vertical line. We write vertical lines as x equals something. In this case, minus 2. This is really the same question again. I've already found these numbers, minus 2, 3. What's the vertex? In this case, the vertex gives us a maximum as opposed to a minimum if the shape was the other way around. And we need to sketch, so we're starting our sketch from that turning point, minus 2, 3. There we go. I'll put it there. It's probably better to find the y-intercept, which will be about here, I think. Let's double check that. So I need another point. I know it's concave down, so I've moved my second point downwards and I've put in my turning point, right? This y-intercept point that I'm thinking of using, I could use any point, but let's go for the y-intercept because that's usually a key thing. That can be found when the x value equals 0. So here's a nice, they've written the equation out for me, right? If I'm on the y-axis, the x must equal 0, so we would have 2 squared, right? That's 0. We're left with 2 squared, that's 4. 4 times minus 4. Minus 4 plus 3 is minus 1. There we go. And that's enough, right? If I was sketching this on paper, I would label that turning point, and I would label this y-intercept. I might even work out the x-intercepts and label them, although you can see they're not going to be whole number answers. Right, so depending on the question. But we could also work out the x-intercepts like I've done in class.